Remember when we learn about a few different mathematical properties and how they pertain to numbers, let us learn how they will be important in algebra when multiplying variables. The most important of this property will be the distributive property. This told us how a number could be distributed across sum of difference. This did not matter too much for arithmetic because for time the quantity of 2 plus 3 is certainly equal to 4 times 2 plus 4 times 3, but there was nothing stopping us from adding 2 and 3 first and then multiplying by 4. We should get 20 no matter which method we choose. But with algebra, there are variables that must remain as they are and cannot be combined with the numbers. So if we have 4 times the quantity of 2x plus 3, the only other meaningful way to express this by distributing the 4 across the sum. That will give us 4 times 2x plus 4 times 3, which will simplify to 8. X plus 12. In algebra, we will want to be able to use this distributive property that way. We will even want to be able to do it in reverse by removing sum or difference. For example, if we have 3x squared plus 6x, another way to express this would involve identifying the greatest common factor of these terms and factoring it out of the expression. In this case, we can rewrite this as this times 3 times x and 2 times 3 times x, taking everything we find in both terms. The greatest common factor would be 3x, and if we pull 3x out both of terms, meaning we divided each terms by 3x, we end up with the 3x out here, and then x plus 2 parentheses. We can rewrite this work as expected by them distributing the 3x sum. 3x times x is 3x squared, and 3x times 2 is 6x. So we can use the distributive property in the variety of way to generate equivalent expressions. Other properties that also apply included the commutative property for addition and multiplication. 2 plus 3 is the same as 3 plus 2, and 2 times 3 is the same as 3 2. If this becomes algebra terms, the commutative property applies in principally the same way. In order in which we added or multiplied algebra term, irrelevant. 2x plus 3 is the same as 3 plus 2x, and 2x times 3 is the same as 3 times 2x. However, let us recall that the commutative property does not apply to subtraction or division, and that will be the case in algebra as well. We also learn about the associative property, and that will apply in algebra too, which we will find out later when we have to manipulate the equations with the lots. Changing the way these are grouped will not matter if we are doing addition or multiplication. To be through, let's also mention some pretty intuitive property like the additive identity property. This will say that you can add it or subtract 0 to any number or algebraic terms, and it will retain its identity. 5 plus 0 is 5. 3x minus 0 is 3x. Seems obvious, but it will came in handy. This multiplicative identity property works the same way expected with the number on stand of 0. Any number or algebraic terms times will give you the same terms again. For x times 1 is a 4x, and lastly the inverse property of addition says that anything plus it is additive inverse equals 0, so x plus relative x equals 0 and the inverse property of multiplications. Say that any 6 times it is multiplied inverse equals 1. So x times 1 over x equals 1. That's pretty much all we needed to know in terms of number property of algebra. So